So we have two types of tied arch bridges or bowstring girder bridges. The first one is RCC bowstring girder bridge. And the second one is steel bowstring girder bridge. The first one, that's the RCC bowstring girder bridge, is used for the spans ranging between 30 to 45 meters. And the second one, steel bowstring girder type bridge, is used for relatively longer spans ranging between 120 to 240 meters. All right, so for shorter spans we have to go for RCC bowstring girder type bridges, and for relatively longer span ranging between 120 to 240 meters we have to go for steel bowstring girder type bridges. And this must also be noted that these bridges are multi-span bridges and can consist of continuous or discrete arches if single arch is insufficient. If single arch is insufficient, continuous or discrete arches can be employed. And let me show you the diagram of multi-span tied arch bridge. With continuous or discrete arches will be somewhat like this. If this is the one support, this is the other support. If single arch is insufficient, we can go for multiple different arches. All right, so this was about the tied arch bridge or a bowstring bridge, in which we combine the characteristics of two bridges, that is suspension bridge and arch bridge. The bridge deck remains suspended below the arches. The bridge deck remains suspended below the arches in case of a tied arch bridge by means of these suspenders or hangers. And the horizontal thrust is carried by these ties or the tying cord, which ties the two ends of the arch together at its springing levels, so that the reactions at the supports can only be vertical and not inclined, as in case of arch bridges, so that we can go for less robust foundations. And these can be particularly used in those areas where there are less favorable soil conditions. And in addition to this, in a bowstring girder type bridge, it projects above the formation level of the road or a railway line for that matter. Hence, the question of accommodating the rise between the level of approaches and the springing level of the arch does not arise at all, thus making it favorable for all those situations where we have to go for multiple spans and the available clearance is restricted or limited. All right, so let's study their advantages and disadvantages. The first advantage of these tied arch bridges or bowstring girder bridges is that they are very strong. The second one is that less force on abutments, because the horizontal forces are borne by the tie rods or the tying cord, so there is less force on abutments, and we can design lighter sections unlike heavier sections that had to be designed in case of arch bridges. Third one, they can be built off-site and transported by subsequently lifting them, hauling them, or floating them into place. All right, they can be prefabricated off-site and can be subsequently lifted, hauled, or floated into place. All right, but with advantages there also comes disadvantages. And the first one is that regular maintenance is a disadvantage. Number one, regular maintenance is required to ensure the stability of hangers at the arch. Regular maintenance is required to ensure stability of the hangers and the arch. Second drawback or a disadvantage is that if one hanger or a suspender breaks, the entire structure can be adversely affected. If one hanger or suspender is or gets breaked, entire structure will be adversely affected, because it are these hangers or suspenders which transmit the load from the deck to the arch rib. So if one hanger or a suspender breaks, the entire structure will be adversely affected. The third drawback is that the size of the span is limited as compared with the suspension bridges. There is no comparison with suspension bridges. They are the bridges that we can go for constructing spans in excess of 900 meters. So the size of the span is limited since we have combined the characteristics of a suspension bridge and tied arch bridge. That is, we have suspended the deck below the arch by means of suspenders or hangers. So the deck also remains hung by these suspenders and is suspended below the arch, but we cannot go for the spans as long as or beyond 900 meters, and as in case of a suspension bridge, which is our only solution of creating longer spans with minimum intermediate piers or supports. This is all these forms of bridges that we have learned so far. The thing that is of foremost importance is this thing, span. How much a longer span we can create in each type of a bridge at each particular different condition without going for intermediate supports or piers. That's why in the video lecture number first itself, wherein we were discussing what is a span of a bridge. A span is the center to center distance between two adjacent piers, abutments or supports. I told you that this thing, span, is one of the most unique and important and fundamental concept or a term in the field of bridge engineering. This all comes down to the span, how longer a span can be created without going for any intermediate spans in between. Anyway, so the size of the span is limited as compared with the suspension bridges. The last disadvantage that we are going to discuss over here is that more expensive to build as compared with other types of bridges of the same length. This type of a bridge, the tied arch bridge or a bowstring girder type bridge, is more expensive to build as compared with other type of bridges of the same length. All right, so this was about the tied arch bridge or a bowstring girder bridge, wherein the two ends of the arch are tied together by a tying cord, which may be the bridge deck structure itself, or it may consist of separate independent tie members or tying rods. And the reason is that, or the advantage of doing or going for this, is that the horizontal reactions are borne by this tying cord and not by the supports. And we are also ensuring that the reactions at the supports are only vertical and not inclined, so that we can go for lighter sections in designing these abutments or supports. And in addition to this, they can also be used in all those conditions where there are less favorable soil conditions. And since the main thing is that the bridge deck, it rises above the formation level of the road, unlike arch bridges where these arches are placed beneath the bridge deck. And what all other advantages and disadvantages are of these bridges, we studied them along with how it derives its name and all. Alright, so this was about our basic 7 forms of bridges. Let's quickly recapitulate. The first one, beam bridge. Simply supported structure, and if we have to go for spans in addition of 80 meters, we have to go for intermediate supports or piers, transmits its load via bending or flexure and not by transferring stresses through arches or cables, unlike other bridge forms. Alright, then we discussed a truss bridge, wherein we employ trusses, which are the triangular units of interconnected elements, and this geometry provides them exceptional strength and stability because they are capable of handling dynamic loads. They can absorb both tension as well as compression. All right. Then we studied the arch bridges, in which arches are used as the main structural component to support the loads of the bridge deck, and these arches are placed beneath the bridge deck. Alright, and the loads are borne here also by bending, because it also, the truss bears it as a beam. Here in case of an arch bridges, the loads are carried particularly by compression, with the reactions at the supports being both horizontal and vertical forces. And vertical forces. Then we studied the cantilever bridge, in which the two ends, this is the cantilever span, also known as the anchor span, which is anchored below the shore, anchor span. This is another anchor span or a cantilever span, a cantilever being a beam which is fixed at one end and free at the other. So here in case of the cantilever bridges, we use projecting beams known as cantilevers, and in the central span, that remains essentially suspended on the two free ends of these cantilever beams, and this is a cantilever type of a bridge. More ideal in case of those areas which are flood prone And we can go on creating longer spans without the need for intermediate piers in case of the cantilever bridges. And the bridge deck is supported by means of these cantilevers in addition to the trusses also, which take the load off the deck and transfer them to the supports or piers or abutments. Then after that we studied about the suspension bridges, in which we use a freely suspended, these are the anchorages, right? So this is a suspension bridge, in which the bridge deck is suspended or hung below suspension cables. These are the suspension cable by means of hangers or suspenders. All right. And the load and the vertical loads from the bridge deck are first transmitted to these hangers, then from these hangers to the main cables, suspension cables, and then to these towers and the anchorages, and then subsequently to the foundations below, because these towers remain essentially embedded in the foundations. Then thereafter we studied the cable stayed bridge, cable stayed bridge, in which the bridge deck is also suspended by means of these inclined cables, which are pre-stressed and are always in tension, and they remain anchored between 2 points. The first anchorage is done on the top of the tower and another in the girder of the bridge deck. Also we studied that by doing so, or by employing this cable and tower system, we can create larger width in the river body, or which these type of bridges are constructed, so that there is no obstruction to navigational requirements or the passing ships or the river traffic whatsoever. So this was about the cable stayed bridge, in which the bridge deck also remains suspended by means of these inclined, nearly straight inclined cables, which are always in tension. And the loads on the bridge deck, they are first transmitted to these inclined cables, and then from these inclined cables to the towers, and then from these towers to the foundations below, because these towers also remain embedded in foundation. And the last basic form of the bridge that we studied today is a tied arch bridge or a bowstring girder bridge. In which the two ends of the arches are tied at springings or the springing levels, which is the starting point of the curve of the arch, by means of tying cord, which can be the bridge deck structure itself or separate independent tie members or the tying rods. And the horizontal forces are borne by these tie members, and the load from the bridge deck is transmitted to the arch rib by means of these hangers or suspenders, right? And by doing so, the reactions at the supports are only vertical and not inclined, hence less robust foundations are required. And the deck, it projects above the formation, this bowstring girdle, they project above the formation level of the road, so the arches are not placed beneath the deck. So the question of accommodating the rise between the springing level and the formation level of the road, it does not arise in case of these bridges, so that or this advantages particularly make them quite suitable for all those areas where an limited available vertical clearance is available, or I may say that available clearance is quite restricted. There is no such case. And the tied arch bridge, it combines the characteristics of two bridges, the suspension bridge and the arch bridge, because the bridge deck remains suspended below the arch by means of these hangers or suspenders. So bridge deck is also suspended in case of a tied arch bridge. So bridge deck essentially remains suspended in three types of bridges: the suspension bridges, the cable stayed bridges, and these tied arch bridges. Now, the beauty of span, here we can go beyond 900 meters. These are ideal for 200 till 900 meters, and here in case of a tied arch bridge we can go maximum up till 240 meters. All right, so this was about the basic forms of bridges. This is essentially a classification based on the type of the superstructure used. Next topic is classification of bridges. All right, now the next topic is the classification of bridges, wherein we'll study the classifications based on various types in case of bridges. All right, classification of bridges. Bridges may be classified in many ways. First one, according to their function. According to function, the bridges may be classified as aqueducts, viaduct, pedestrian, highway, railway, road cum rail, or a pipeline bridge. So, on the basis of function or according to function, bridges can be classified as aqueduct, viaduct, pedestrian bridge, highway bridge, railway bridge, road cum rail bridge, pipeline bridge. All right. Aqueduct, it's a bridge which carries an artificial watercourse. It carries an artificial watercourse. So that bridge which carries artificial watercourse is known as an aqueduct. Viaduct, it is a specific type of bridge that consists of series of arches, piers or columns supporting long elevated railway or road, allowing direct pass but across a wide valley. Let me drop it first and explain it to you. So aqueduct is that type of bridge which carries an artificial watercourse. Viaduct, it is that type of a bridge that consists of series of arches, piers or columns which supports a long elevated railway or road, allowing direct overpass over a wide valley, or across a wide valley. That type of a bridge is known as a viaduct. All right, next one, pedestrian. That type of bridge which will be used by pedestrians is known as a pedestrian bridge. Highway, which is used for vehicular traffic. Railway, for the rails or the railway lines. Road cum rail, which has dual function, that it can serve both for rail traffic as well as road traffic or vehicular traffic. And a pipeline bridge, which carries a pipeline across any obstacle. So this was the classification of bridges based upon the function for which they are used. Next one, according to the material of construction. According to material of construction of superstructure. Superstructure is that part of a bridge which is above the level of the bearings. That portion is known as a superstructure. So based on the material of construction of superstructure, we have timber, masonry, iron, steel, reinforced concrete, pre-stressed concrete, composite, or aluminum bridge. I will write it down for you. So based on the material of construction of superstructure, we have timber bridges, wherein the superstructure is constructed of timber. We have masonry, wherein the superstructure will be made out of stone masonry or brick masonry whatsoever. Then iron, wherein we'll employ iron. Then steel, reinforced concrete. We have pre-stressed concrete bridges. We have composite, wherein two different materials are used for construction of bridge superstructure. And then we have aluminum. All right, so this is the classification based on the material of construction used for the superstructure. We have timber bridges, masonry bridges, iron bridges, steel bridges, RCC bridges, pre-stressed concrete bridges, composite bridges, or aluminum bridges. All right, next one is the classification according to the form or type of superstructure that we were discussing during all the lectures that were held previously and in this lecture as well. All right, so the classification based on the form or type of superstructure. What form or type of superstructure we're employing? We have classification of bridges as slab bridges, beam bridges, or girder bridges, wherein beams are spanned across two abutments and the bridge deck is placed across these parallel beams, and the bridge loads are transferred to these beams directly without transferring the stresses via arches or cables. We have beam bridge or girder bridge. Then we have truss bridge. Herein the bridge deck can be constructed. If we're going for solid slab bridges, then that decking is of slabs. All right, now beam bridge, girder bridge, truss bridge, arch bridge. We have cantilever bridge. Then we have suspension bridge. We have a cable stayed bridge. And we have a special bridge which combines the characteristics of suspension bridge and arch bridge, that is known as a tied arch bridge or a bowstring cutter bridge. Alright, so this is about the classification of bridges based on the form or type of superstructure. We have discussed all of them. Next classification is based on interspan relations. Span is the center to center distance between two adjacent supports, pairs or abutments. Now the fourth classification of bridges is according to interspan relations. According to interspan relations, the bridges can be classified as simple, continuous or cantilever bridges. Simple bridges, continuous bridges, and cantilever bridges. This is essentially a classification based on the interspan relations. Alright, so the simple bridge spans directly between two supports. This spans, let me write it over here, simple bridge is that type of a bridge which directly spans between two supports. A continuous bridge is that type of a bridge wherein along its length we have beams supported continuously, or we can say that multiple spans with continuous support along the bridge. Continuous bridge has a beam supported continuously along its length, or we may say that multiple spans with continuous support along the bridge. We have multiple spans with continuous support along the bridge. Continuous support along the bridge. Alright, so this is the continuous bridge. Then we have cantilever bridge, wherein projecting beams known as cantilevers are used, and it essentially has three spans. Two outer spans are known as anchor spans, and the central span is known as the suspended span. This is the suspended span. This is the suspended span which rests on the two free ends of the cantilevers. These are the anchor spans which remain anchored down to the shore. Alright, and in addition to this, trusses can also be employed which can carry the load of the deck and transfer them to the supporting piers or abutments. So this was a classification based on the interspan relations, wherein we have simple bridges, continuous bridges and cantilever bridges. Next one is the classification based on the position of the bridge floor related to the superstructure. Position of bridge floor relative to superstructure. Here in this type of classification we have deck through, half through and suspended bridges. Deck through, half through We have deck through, we have half through. And we have suspended bridges. Let me show you diagrammatically. This is the classification based on the position of bridge floor relative to the superstructure. The first one is the deck through bridge. When the supporting elements like trusses, girders and arches are below the bridge deck, then the bridge is known as the deck bridge. Right? Where all the trusses, which essentially support the bridge deck, can be trusses or maybe girders or maybe arches, whatsoever we are employing to support the bridge decking above. If they are placed or lie below the bridge deck, then the bridge is known as the deck bridge. For example, let me take example of any of the above. Let's see arch bridge. This is the arch. This is the bridge deck. All right. When the supporting elements are placed below or beneath the bridge deck, then that type of a bridge is known as deck bridge. All right. Then we have another type of bridge that is known as throw bridge. It is that type of a bridge wherein the bridge deck, I'll show you diagrammatically. It is below the supporting structure. We just studied tied arch bridge. All right. In this case, this is the deck and this is the arch. And the deck is below the supporting structure. All those bridges wherein the deck remains below the supporting structures, that bridge is known as through bridge. That means our tight arch bridge or bowstring girder bridge is a through bridge. Then we have essentially the second classification based on the position of the bridge floor related to the superstructure. We have essentially divided deck through in deck and throw bridge, wherein the supporting structures lie below the bridge deck, and here the bridge deck lies below the supports. There is only one special such case, that is in case of a tied arch bridge. All right. In some cases, the deck is located at the middle of the supporting structures. Those types of bridges are known as half-through bridges. In some cases, we have the deck that is located at the middle of the supporting structure. I'll show you diagrammatically. If this is the bridge deck and this is the arch, it's tied over here, and this is the arch, and this is the bridge deck. So the deck is located at the middle of the supporting structures, and this forms a half-through bridges. The next classification based on the position of bridge floor related to the superstructure, we have suspended bridges. Wherein our tied arch bridge also follows under this category as well, in addition to the through bridge. We have suspension bridge, we have cable stayed bridge, and we have, so the classification never remains mutually exclusive. One bridge form can fall in another category as well. We have tied arch bridge as well. In all these cases, the bridge floor remains suspended below suspension cables. In case of suspension bridge, below inclined cables, or suspended by means of inclined cables in case of a cable stayed bridge. And in tied arch bridge, the bridge deck also remains suspended below the arch by means of the hangers or the suspenders. So this was about the classification based on the position of the bridge floor relative to the superstructure. Next classification, and you also noted here that the classifications are not mutually exclusive. One type may overlap with another type as well. All right. Next one is according to the method of connections of different parts of the superstructure, particularly for the steel bridges in case of steel construction. This classification is based on the method of connections used, and accordingly, as per this classification, we have the pin connected, we have the riveted, pin connected, riveted, and welded bridges. All right. So this is the classification based on the method of connections, and this is particularly for all steel bridges, and the classification is that the bridges can be pin connected, riveted, or welded bridges. All right. Moving on, next one. It is according to the method of clearance for navigation. The classification based on method of clearance for navigation. We have movable bridges, we have bascule bridges, we have the swing bridge, vertical lift bridge, and we have a floating or a barge bridge. Floating or barge bridge. So this is the classification based on the method of clearance for navigation. We have the movable bridges, bascule bridges, swing bridges, vertical lift bridges, floating bridges, or barge bridges. Now let's discuss what are these type of bridges. All right, first one. Movable bridges are those bridges designed to move to allow traffic in waterways. They can move to allow the traffic in waterways. All right, so that is known as a movable bridge, which moves to allow the navigational requirements, and it moves so that it can provide a passage to the river traffic beneath the bridge. That type of a bridge is known as a movable bridge. So this is the generalized classification of those bridges which permit the movement of river traffic in one way or the other. Then how they can move or how they can accommodate this river traffic. So this was a generalized term. Now we will go one by one. Bascule. How these bridges can accommodate the river traffic requirements whenever that need arises. Bascule bridge. Bascule bridges can be rotated about a horizontal axis at one end or both ends of the bridge deck. So that type of a movable bridge wherein bridges can be rotated about a horizontal axis, all right, at one end or both ends of the bridge deck. All right, so a bascule bridge can be rotated. It's that type of a movable bridge in which the bridge can be rotated about the horizontal axis at one end or both ends of the bridge deck. Next one, swing bridges. Swing bridges. It is that type of a bridge which can be rotated about a vertical axis. It can be rotated about a vertical axis to swing sideways for allowing the movement of traffic. Allowing movement of traffic, all right? So this is about the swing bridge, which can be rotated about a vertical axis to swing sideways for allowing the movement of traffic. Next one is vertical lift bridges. Vertical lift bridges are those type of movable bridges wherein they can be lifted vertically upwards for the free passage of traffic. Vertical lift bridges. Vertical lift bridges. These are those type of movable bridges. The movable is the generalized term, wherein they can be lifted vertically upwards. They can be lifted vertically upwards for the free passage of traffic. Next one is a floating bridge or a barge bridge. This is that type of a movable bridge where a barge or a floating part of the bridge deck can be floated out of the way for the passage of water traffic. So a floating bridge is a barge or a floating part wherein we can move the floating part of the bridge deck it can be floated out of the way so that traffic can pass by. to allow river traffic passage of it. All right, so this is that type of a movable bridge, wherein the bridge deck consists of floating structures or barges which can be floated out of the way just to allow the river traffic to pass by. All right, so this was the classification based on the method of clearance for navigation. Next one. According to the road level related to the highest flood level. This is classification according to road level relative to HFL. All right. According to the road level related to the highest flood level of the river below, we have highway bridges as high level bridges or submersible bridges. So we have high level bridges and we have submersible bridges. High level bridges are those bridges which are designed by taking HFL of that particular area into consideration, and the bridge deck or the vertical clearance, it essentially remains good enough so that the flood waters will not pass over the bridge. Whereas in case of submersible bridges rather, these are designed intermediate in between the highest flood levels of that particular river wherein these are constructed, so that they may serve as dry bridges wherein there are no floods, but in case of floods they may get submerged. So that's why they are known as submersible bridges. That means HFL is, there is no good or apt amount of vertical clearance, and during floods they can get submerged. So this was according to the road level related to the HFL, wherein we have to see that during the floods whether our bridge will get submerged or will it remain high above the HFL of that particular river wherein we are constructing these river bridges. Next one is the classification based on the length of the bridge. All right, so according to the length of the bridge is the total length between the inner faces of dirt walls. First you must note that total length of the bridge is the length between inner faces of dirt walls. What is a dirt wall? It's a small retaining wall beyond or behind the bridge seat, linked between inner faces of the dirt walls and its structural component of abutment. All right, so the classification is based according to the length of the bridge, wherein by total length of the bridge I mean the length between the inner faces of the dirt walls. We have culvert, minor bridges and major bridges. Culvert, minor bridge, and a major bridge. All right. Culvert is that type of a bridge which has total length less than 6 meters. minor bridge is that which has length between 6 to 60 meters. Total length. This is not of span. I am referring to the total length, which is the length between inner faces of the dirt walls. And the major bridge is that type of a bridge wherein the length is between, or I can say above 60 meters. All right. So this was about the culvert, minor bridge, and the major bridge, wherein culvert has a length which is less than 6 meters, minor bridge has 6 to 60 meters, major bridge has above 60 meters. And we can also classify the length as per span, long span bridges, wherein the main span of the major bridge is above 120 meters. That is known as a long span bridge. And span, you know, center to center distance between two adjacent piers, abutments or supports. We can also classify a long span bridge according to the length of the span, and if it is a long span bridge, it has a span length in excess of 120 meters. All right, so this is about the length of the bridges, or the length of the span, the total length of the bridge or the length of the span, and accordingly we classified the bridges. All right, the next one is according to the degree of redundancy. According to degree of redundancy. All right, this is the next classification. It's based on degree of redundancy, and accordingly we can have determinate or indeterminate bridge. We can have determinate or indeterminate bridge. This is the first one, classification. The second, indeterminate. All right. We can have determinate bridges or we can have indeterminate bridges. This is the classification based on the degree of redundancy. All right. The next classification that we are going to study here is according to the anticipated type of service and duration of use. According to anticipated, this is a classification based on or based according to anticipated type of service or duration of use. All right, so the classification based on the anticipated type of the service and the duration of use, we have permanent, temporary, military bridges. We can have permanent bridges, temporary, and military bridges as well. Where in the military bridges, we have essentially pontoon bridges and the Bailey Bridge. All right, pontoon and Bailey Bridge. This is a classification based on the anticipated type of the service and the duration of use, permanent or temporary. Permanent, which are we going to construct permanently and won't be removed after certain use. Temporary, which we make for some temporary situations. And then we have military bridges, which are used for military exercises. And in that type of bridges, we have essentially two bridges, the pontoon bridges and the Bailey bridges. So this was about the classification of bridges, wherein we classify the bridges on various types based on different things, based on the function, based on the material, based on the form of superstructure, on interspan relations, on the position of the bridge floor related to the superstructure, on the method of connections, on the road level related to the highest flood level, on the method of clearance for the navigation, on the span, the length, the redundancy, and the anticipated type of use. And as already discussed, these classifications, you must bear this in mind, they are not mutually exclusive. are not mutually exclusive. Any one type of the bridge may overlap with the others. For example, let's take an example. There can be a multi-span, let me write it down. There can be a multi-span highway bridge consist of steel trusses of through type, all right, be a high level bridge over a river, over a river. So these classifications are not mutually exclusive. Any one type may overlap with the others. For example, we can have a multi-span highway bridge which may consist of steel trusses of the through type and maybe of the high-level bridge over a river. Multi-span classification based upon the interspan relations. Highway bridge classification based on the function. It may consist of a steel trusses classification based on the material used for constructing superstructures. Through type, it is a classification based on the position of the bridge floor related to the superstructure. It may be a high level bridge, that is, it's a classification based on the road level related to the HFL, and it may be a highway bridge or a high level bridge over a river. That means it's a river bridge and not a road bridge or other. All right, so these classifications are not mutually exclusive and any one type may overlap with the other. So this was about the classification of bridges. So we have completed bridges, we have completed the components of bridges, we have completed basic forms of bridges, and we have also completed the classification of bridges. With this, I conclude this video. Thank you for watching.